Well, welcome to this online revision session for AQA FP1, in which we will be considering the June 2011 question 3 on complex numbers. Well, in the first part of this question, we're given the fact that z is equal to x plus iy, remembering that I is the square root of -1. So x is the real part and y is the imaginary part of this complex number z. And in the first part we have to multiply out and simplify z minus I times z star, where remember z star is the complex conjugate of z. So we know that z star is going to be equal to x minus iy. Alright, remembering that the imaginary part is the negative, is the opposite to the term that we were given, okay, when we do the complex conjugate. So z minus I, well, if we got x plus iy, or y lots of I, and we subtract another y, that makes this, when we replace it with x's and y's, equal to x plus I times y minus 1. And then when we do z star, that's going to be x minus iy minus another y, so that will become x minus I times y plus 1. Okay, so now we've got to multiply these out, so we get x times x, which is x squared, and then we've got x times the y lots of y minus 1, so that becomes I times x y minus 1, and then similarly we're going to get minus I times x times y plus 1, and then finally we've got minus I times y minus 1 times y plus 1. So we've got x squared, now that's a real term, so it's got no i's in it, and we know here, when we multiplied the I y minus 1 by the I y plus 1, this should have been I squared here. So I squared is -1 by definition, times the minus, so that's plus 1. So this will be a real term, and y minus 1 times y plus 1 is y squared minus 1, because this is the difference of two squares. So this just becomes y squared minus 1. So that's our real part, so I can put a bracket around that to show that this is my real part here. Then the i's appear here and here, so we know it's then going to be an I. Question is, what is it multiplied by? Well, we've got y times x, and we got a y times an x here, but that's the negative of this one, so they will cancel. Then we got y times minus x, start again. We got x times minus 1, and we've got another x times a 1 with a negative, so that gives us minus 2 lots of ix. Yeah, just point that out again, just to make certain we got that right. We've got i's in both of these, so we've got x times y and x times y, but this one's positive and this one's negative, so they cancel out. Then I get x times minus 1, I've got an x times a plus 1, but that's negative, so that becomes minus 2ix. So this part is my imaginary part. Okay, so that is in the correct form that we require. The real part clearly identified and the imaginary part clearly identified. So, for using the complex conjugate in whatever we do, we'll get a method mark. For then substituting in carefully, we'll get a second mark, and then simplifying it down, and then obtaining the actual correct simplification will give us a third mark in there. Okay. We're then given the fact that z minus I, z star minus I, complex conjugate z minus I, is equal to 24 minus 8i. And we've got to find the possible values of z. Remembering that z is x plus yi. So, I can write the fact then, because I know from part A that I've just worked out the fact that z minus I, z star minus I is equal to x squared plus y squared minus 1 minus 2ix. And that must equal 24 minus 8i. So the technique here is to then compare the real part with each other and the imaginary part with each other. So we can see, if we look at the imaginary part first, we've got minus 2x equals minus 8. Remember, when we compare the imaginary parts, the i's are in both parts, and it's the coefficients of the i's which is the imaginary part. So we have minus 2x equals minus 8. So that clearly tells us that x is equal to 4. Now we can compare the real parts, and that is then the fact that x squared plus y squared minus 1 equals 24. We know x is 4, so that is 16. So y squared must be equal to 24 minus 16 is 8 plus the 1, so this is equal to 9. So that is telling me that y can either be positive or negative 3. That's where your two solutions come from. And so, substituting your value of x and your possible values of y back in for z, we can say that z is either going to be x, which is 4 plus 3i, or it's 4 minus 3i. Notice more typically that when you're solving this type of problem involving equating the real and the imaginary parts, more often we end up with a pair of simultaneous equations to solve rather than just a single variable from which we got x and then we're able to substitute it back in straight away. More typically, you get a pair of simultaneous equations. Anyway, where do you get your marks then for the 4 marks? Well, identifying the real and the imaginary parts will give you a method mark. Stating this value of x from one of those equations gives you an answer mark, and then an appropriate method mark for substituting back in to find y and obtaining the two possible values, and hence the solutions gives you your 4th mark to this section of the problem. Well, hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.